Alright guys, I mentioned in part 2 that your comments, suggestions would dictate the direction I'm going to go for the next one, and it did. And what I want to do with you guys today is I want to show you the cranking vacuum test using the map sensor. I left off with this particular waveform. I know we're a little bit more zoomed in on it. What this one was is our idle one, and if you guys remember, we kind of ended the video with saying we really couldn't make heads or tails out of a problem in here with it idling. And you know, I think for a few reasons. One, our problem isn't that bad of a sealing issue. It's there enough to give us a little bit of roughness. It's there to cause the engine computer to see that variation in the crankshaft instead of misfire trouble code, but really not enough to see in this waveform. And I think, again, I was a little bit more zoomed in with this, is where we kind of left off. It was pretty much something like that. And a few thoughts on this before we continue. Again, what I was telling you guys from this point here, this is my #1 firing event, and all the way over here at the other side, here's my #1 firing event again. So there's 720, and what we can see in here is we have 5 different unique patterns, or 5 different intake valve openings and closings. There was a comment that's coming to mind right now that said, hey, this is a 5-cylinder engine. It fires every 144 degrees, and you would be correct. We have a cylinder firing every 144 degrees. But when we are doing strokes for a single cylinder, it's still only 4. It's a 4-stroke engine. So my partitions right now, you see I just changed it to 4. And what we have from here to here is 180. From here to here is 180. From here to here is 180. And from here to here is 180. So it's a different subject altogether than it is talking about the firing events. I'm talking about the strokes. When I did this part, I was talking about the strokes of this #1 cylinder. That's what we're looking at here. And this would be what we said. This would be power. Why? Because right here is where spark occurs. This is my exhaust. This is my intake. And this one is my compression. And again, I do not have these exactly timed for valve opening and closing. We weren't too concerned about that. We're just looking in general, and this 180 degrees, right? This is top dead center compression, and it's not exactly top dead depending on ignition timing advance at idle. This is top dead center compression. This would be bottom dead center, so this cursor right here would be bottom dead center, and this is the next cursor right here. This is top dead center again, and right here is bottom dead center. And then back to over here, that event TDC compression again. And once again, I'm not saying that's true top dead center compression. Depends on where the ignition timing is. And those are our strokes. So if we're talking about the #1 cylinder, forget about the rest of the blue waveform here. The #1 cylinder is my concern. What happens with the power stroke? Where are the valves? They're closed. During the exhaust stroke, which valve is open? The exhaust valve. During the intake stroke, which valve is open? The intake. And then during the compression stroke, both valves are closed. And what we want to look at for the intake pocket for the #1, if you want to call it, would be this one right here. And again, we're worried about valve sealing problems. Some of you commented and are backing me up on this. With a valve sealing issue, we're not really worried about this area. Where we're worried about would be during the compression event of that number or whatever cylinder. That would be when we really want to pay attention to this waveform, because once we draw the air in, then the valve closes, then we're going to compress it, and that's where the piston, we're coming back up from bottom dead center, and in that area would be where we would potentially see a #1 cylinder valve sealing issue. Now, number 1 was not our issue, it was number 4. Anyway, a lot of stuff in there, and I don't have that maybe down 100%. I'm getting there. What we said from this pattern is I don't think we could pick that out and say we had a valve problem at idle. Let me come out a little bit more to show you just a couple of patterns there. And that was our idle pattern on this vehicle. And what we had done too, again with our strokes, you see them here, this is 180, 180, 180, 180. What we said was number 1 intake would have been this one. And then we plugged in our firing order from there, which was 13542, 13542. So that's where we left off. All right, let's take a look at this at idle. Or is there anything else I wanted to cover with you first? Yeah, I guess we could do this. The rulers, let's throw 5 of them in there now. And now what I'm showing with my cursors in here, so we have 5 partitions now. Okay? What I'm showing now is this dotted line here, this dotted line here, and so on. These would be your cylinder firings. So we have number 1 firing here, and then we have number 3 firing roughly in here, number 5 firing here, number 4 here, number 2 here, and then back to number 1. So don't get the strokes mixed up with the cylinder firings, and I think some of us were doing that. All right, let's look at the cranking waveform. So this would have been the first one I took today. And what's cool about this is the waveform and how I took it. And what we have is our map sensor, the blue trace, and our red channel again is my number 1 ignition coil firing event. I did misquote that once in the last video, calling that an injector firing event, but I did put a correction note in there, and hopefully you guys all saw that. I saw a comment that maybe I didn't and I screwed up, but that is not an injector firing. The red trace is a coil firing event. Nice thing with the Pico, we can take this on a regular scale, 5-volt scale for the map, and then we can zoom in on that. So that's what I'm doing here. I'm just going to take this area and we'll zoom in on that. There's 720 of the crank. I know that's 720 of the crank because of my 2 red coil firing events on here. They're 720 degrees apart. I already have the cursors in there. And what we can do is we can zoom on that just a little bit more, and we can really emphasize what that looks like. This would be our cranking waveform. Now to maybe show you a little bit of repetition, what I can do is just come out a little bit. That might be too much. We'll take a look at that for a second. Move this over. I can see a little bit more clearly that there's some erratic behavior here. And one of you had mentioned something that I came to the conclusion of with this is I believe we have multiple cylinders that have a problem. I didn't do a leak down test on the entire engine. Now we're just going by the Misfire monitors on the number 4 showing up on the scan tool. I'm sure if this has a seat problem on number 4 that some of these other ones are leaking too. And it almost looks like, you know, if we were to do, I guess I could do it quick. You know, nothing I do is quick, is it? If we were to look at this again and put our stuff in here, this is power, exhaust, intake, and then compression. So I'm looking at these cursors here. Number one intake we're saying is this one. I'm saying that this is the number one intake stroke right here. And then going backwards, well, we can go in firing order. This would be number 3. This would be number 5. This is number 4. This is number 2. And again, we're not really worried about where the intake valve is opening in these pockets so much as we are the next stroke is the compression stroke. That's what we're worried about. Let me write this backwards here. So this will be 2 right here. And this is 4. This is 5. Just to get the other numbers in there for where my degree cursors are. So if we were looking at number 1 on the intake, which is this one, where would we be worried about the valve sealing issue? I would think that it would be somewhere in here that we would want to be watching. And if we were looking at, say, the number 3, we want to be looking somewhere in here. The number 5, somewhere in here. And then the 4, number 4 would be somewhere in here. I just think it's interesting that really, to me, the one that sticks out is this area. And it seems that, you know, that's right after the number 4. So that was one thing we saw. And then really looking at all of these, I'm wondering if the pressure rise in these sections, let me clear the ink here for a second. I'm wondering if the pressure rises in each of these sections are not valve sealing problems, and that really what I have is maybe one good one. And the rest of these all are exhibiting some signature there of a pressure rise from valves that are leaking. It could be that. I'm not totally sure, but I think that's an issue. All right, let's address another question. Why did I use an ignition sync? Can I maybe be a little bit more clear if I use an injector pattern to synchronize this? So let me show you that one. And really, my thoughts were, hey, that's a great suggestion because maybe I can figure out that I'm plugging in my numbers correctly here using an injector firing event. So let me show you that. Cranking, map, injector. So I got map, the injector, and the coil in this one. And that's the pattern. And again, this is number 1. Number 1 coil, number 1 injector. Why am I using these? I don't want to take anything apart. I can get to the number 1 injector. I can get to the number 1 coil without taking the air box off on this car. So let's look at maybe this area first so everybody has perspective here. Green trace would be injector on and off. This would be the turn on of the injector right here. And then the turn off would be right there. And the spike that we're looking at would be the turn off of the fuel injector, just so you have the right perspective there. And then the red trace, of course, is the same as what it's been. That is our spark. The trailing edge is the spark. So let's now zoom in on the map sensor and take a look at that. Again, green trace is my injector pattern. Get some detail in here. And then let's just throw in our degree cursors again. And why am I placing this degree cursor at that location? Because that is where a spark is occurring. And then place it there again. There's 720, and then what I want is my rulers. Good, I'm at 4. So we can now look at our number 1 cylinder. Our power stroke, exhaust stroke, our intake stroke, and our compression stroke. It's a 4-stroke engine. I don't care that it's a 5-cylinder. It doesn't matter. We have 4 strokes. Look where the injector's firing. The injector for the number 1, the spark for the number 1 occurred right here. Where's the injector firing? Here's your injector firing for the number 1. This is number 1 spark. This is number 1 injector. It's firing somewhere on the power stroke. We've already fired the injector. Now let me ask you guys something. What position is the valve in during the power stroke? Valve's closed. Intake valve specifically. Can we spray fuel in that area while the valve's closed? Yes, we can. During the exhaust stroke, that intake valve's still closed. So we have fuel in there, say from here, right? We still have fuel in that pocket. And then during the intake stroke, somewhere in here we have some valve overlap. So that's where the fuel is going to be drawn into that cylinder. The intake, then we compress it again, and then we fire it. So you guys tell me, here's the number 1 injector sink. How is that helping me find the number 1, which I'm saying that's the number 1 intake? I think we were better with the spark. And here's the thing. Every car works a little different in when they fire this injector. There is no set standard for that, not that I'm aware of. Now maybe I'm wrong on that, but I don't see where sinking this off of the injector is going to help me at all. And the reason I chose to do it is I wanted to make sure, I'm saying that this is the number 1 intake opening, and I just wanted to know that I was correct in saying that. And so I thought that was a great suggestion. Let's try the injector. Maybe I should have been using the injector, and what we find here is no, that injector's firing way before that intake pocket. So cranking again, zoomed in to put the rest of the numbers if we're doing this correctly. 1, 3, 5. All right, that's 5 over here. 4 and 2. And again, I don't like this area, but I don't know enough to tell you what's going on. Multiple cylinders is what I think we have. So what I decided to do, as some of you suggested, man, we need to start baselining this if we're going to start using it. Which, by the way, let me come back to this picture. I believe the cranking test was the way to go, and the reason for that, with a valve sealing issue, as some of you stated, reason for that is there's more time for those pressures to escape. The RPM's very slow. If you have a valve sealing problem, you're going to see it at lower RPMs. So it was a great suggestion to do this during cranking. In fact, if I do this in the future, I believe that cranking is going to be the answer. And we see something. I can see a low one consistently. Now, we can debate on the cause. Are we looking there, or are we looking at this one? You know, where should our eyes be? Or one more time, is it all of these that we have an issue except for that one and that one? Is that my only good one? It might be on this vehicle that's known for valve seat problems. So let me show you another car. We had some of my students' cars in here today, and we took some pictures. This will be a Neon, 2001 Neon. And I didn't bother with the injector. In fact, sinking this one, I didn't care at all. What we did is we just cranked it, set my scales up on a 5-volt scale, and in the first area in here, the engine is off, keys on, and then we start to crank it, and so this is what the waveform looked like. And you know, we can maybe zoom in on a little bit more of those. It's a 4-cylinder engine, so look at repetition. Man, look how clean that is. So that almost further confirms that we had multiple valve issues. And some of you mentioned a first look sensor, and I'm in agreement with you. I want to have a first look sensor. I don't have one. I will be ordering one for sure. primarily because a lot of our cars do not have map sensors that I can do this on. I don't think with the map sensor though, I don't think it's an issue of detail that I need a more detailed waveform, as some of you suggested. This is pretty detailed. Let's look at this thing now at idle. This is on our car with no known issues. This is the idle picture of it. Little up-down oscillations on the screen. You can see hovering around 1 volt. And yeah, let's zoom in on some of that. These are a lot more consistent and uniform, I think. But then we really zoom in on it, we see hash in there. But I think it's a lot more consistent than our Hummer at idle. Let's see, I don't know if this will work. Let's try it. I'm going to create a reference waveform here. It depends on time bases and RPM for the 2 engines, if I can even show this well or not. I'm going to reopen my map at idle on my Hummer. Let's get a little perspective of that. And don't need the red channel. Don't worry about the red channel. Yeah, I don't know. Again, idle was pretty tough to see. Kind of confirming that our cranking one was the way to go. Cranking was smooth on this neon. That's idle. There's cranking again on the neon. Look at that. That looks pretty cool. That's pretty clean. Let's try that one more time. Get rid of these. This is the neon. This is my Hummer cranking. Pull that reference waveform in there. That's way up top. Yeah, just my scales. Scales are different on that one. And my RPM's different too, so this isn't going to be a good comparison together looking at these. So let's just do them separate one more time. Map cranking on the neon, good engine. Cranking on my Hummer. Yeah, there's definitely something there. I like it. All right, let's look at one more. Chrysler 300 cranking. Just the cars I had out there with map sensors. This is the 300. That's what that line looks like. I was cranking. We zoom in on that. We keep zooming. We have some detail. And that one looks horrible. And the thing is, with this Chrysler 300, it's in for an ABS light. It's not in for a misfire. Looking at this, it almost looks like there's valve problems with this engine. So I think I need to do more of this, because I don't like that. You know, that neon was perfect, and then looking at this 300, certainly looks like something's going on there. And it's a 3.5 in this 300 if anybody cares. And then last one would be the 300 at at idle. That was cranking. This one's at idle. And there's a lot of noise in that for sure. So 3 different cars, 3 different systems. Is this worth doing more of? Definitely. Did we see something? I think so. Your suggestions are great. I really appreciate them. All right, what's coming up next after this is I revisit the in-cylinder pressure transducer using the Pico. I revisit the leak down on the number 4 and the number 5. You know, after seeing the rest of these on this waveform, we'll go back to the cranking of the Hummer. You know, I almost want to put air in the rest of the cylinders, but I don't care at this point. You know, the purpose of what we're doing here is, again, trying to develop other testing methods to identify valve problems. In particular, when you can't get to the spark plug. Intake manifold covers it, can't get to it. You want some other test that will point you in this direction. But if we think about this one too, we're trying to synchronize it and figure out what's what. I think in reality what you'll have is you're going to have misfire symptoms. You're going to have a roughness. You're going to have a trouble code. And most likely when you get the car, it's already had new plugs, new wires, if it has wires, and a bunch of parts thrown at the car and they can't fix the misfire. Is that going to be a time when we want to visit our pressure in the manifold, whether using, say, a first look sensor or the map sensor, and see if we have irregularities? And if we do, can we say, just by looking at this, can we just say we have a valve problem? And do we really care which one it is? I don't know, not necessarily. So I think that's cool. Let's develop it. Let's get more waveforms. So you guys can help me with that. Hey, you know, you get some waveforms on some other cars, throw it on Google Plus so we can all look at it. You guys that haven't followed me yet on Google Plus, do it, because that's a place we can post images and pictures, and it's a little bit easier to talk to each other over there than it is on posting comments here on YouTube. So that would be cool. Maybe a little homework project. All right, for those of you that don't have a scope like this, just show you what I did. You know, the Pico has a great zoom, you know, that I can see this type of thing up here, which is hovering around 5 volts if you look, guys. So for different scopes out there, this has to be done a different way. If you look at this, what you'll see is there's 4 volts right there. There's 5 volts right there. So I'm up here. How do you get the kind of detail? So we want to zoom in on this section. How do we get that kind of detail on a different scope? What you need to do is you select AC coupling. If you AC couple it, if we AC couple the scope, what we will do is I think I spelled couple right. In case I didn't, I'm going to erase that. AC coupling, what that's going to do is it'll block this DC constant and it will only show the up-down oscillations. And so now what we'll be able to do, instead of being on a 5-volt scale, we can drop our voltage down to, say, 500 millivolts, and it'll bring my line down at 0. And then what we can do is we can fill the screen, because now our screen, instead of being a 0.5, is a 0 to 500 millivolts. AC coupling. That's what you have to do if you don't have the zoom feature that the Pico has. So what's coming up next? In-cylinder pressure with the Pico. And I revisit the leak down test. And I did make some mistakes in comments, such as, you know, checking the radiator for a leak. That is also an area when doing a leak down test, although head gasket was never our concern based on symptoms. But that is a valid point. I didn't mention that. So I revisit that and I touch on those things. And I did mention the bore scope was not fruitful at all. We couldn't see anything. Let's get our Hummer picture back in here while we're looking. While I'm talking. I didn't see anything with the bore scope. So what may end up happening is we may end up just pulling the cylinder head off and looking, and you know, as small of a leak this is, there's a possibility that I don't see it with the naked eye, and you guys are just going to have to take my word on this. You know what, for sure, as much time as we're spending on this, for sure, when this is done, whether they get another engine for this or put a head on it or whatever the plans are, I will get some waveforms for you guys, and I will I'll shoot another video, or I'll post them on Google Plus, the after waveforms. So appreciate your time and attention. This is the type of thing that I am going to be doing more of on my premium channel. In fact, I have a case study on a Cavalier. It's going to be 5 or 6 parts where we do direction, and we pick tests, and we attack it from different angles, and we figure out which tools in our toolbox we can use. And I'm equating these tests that we're developing to tools in our toolbox. And that's the kind of stuff I'm going to be doing on my premium channel. And of course, I'll still feed stuff in here too, guys. I appreciate all of you, whether or not you're subscribed to that premium channel. Thank you so much. Hope you guys have a great evening.